This lesson is on exponential growth and decay, increasing and decreasing, and I have some formulas I need to share with you. So here's the first formula I'm going to share with you. This is if it's growing. In this formula, a times 1 plus r to the exponent t, this is a growing function where r represents the rate, t is the time, a is some scalar multiple of some sort, and it's connected. Now I want you to notice what's the difference between that and the decay formula is instead of adding, the rate is not positive, but the rate is negative. Everything else is the same. So we're going to use these two formulas. The one on the left, if it's growing, the one on the right, if it's decaying. A is going to be our initial amount. R is the growth rate. T is the time, whatever the length of time is. And we're probably going to have to use a calculator today. So you can use Desmos. I have a calculator that we'd be using in calculus, so if you see it. But really any calculator will do as we do it together. So you will need a calculator or a Desmos, or you can just follow along and it's fine. So let's read the story and see how we do. Brooke started her career with an annual salary of $32,000. That's what A equals. That's the initial amount. Each year thereafter, her salary increased by 2.5%. So the rate of increase, and we have to write it as a decimal. So I know 2.5 is a decimal, but not a percent sign. So I move the decimal back 2. So 2.5% means the same as 0.025. And then how many years? T is equal to 30. Then we just plug in with our calculator. So the answer is going to be 32,000, 1 plus 0.025, and then to the exponent 30. Just type that in your calculator, and the answer is $67,122.16. I know you can just go plup, plup, plup with your calculator. The important part is reading, analyzing, setting it up, and then I know the calculator can do that. I'm going to move my camera over a little bit more here. So, number 2. There's number 2. You can see my camera right here in front of me. I'm trying to avoid the sun through my blinds. All right, in 1995, a magazine had 14,000 subscribers. The number of subscribers increased by 40%. That means the rate as a decimal is 0.4. And write and use an exponential growth function to find the number of subscribers in 2016. So how many years went by? 95 to 2016. That's 16 plus 5. That's 21 years. And then what's the setup? It's 14,000. 1 plus, because it's increasing. And that's what you put in your calculator. And that would be 16,398,978 subscribers. Done. Number 3. Kate drank an energy beverage. I'm going to avoid the sun. Here we go. Kate drank an energy beverage with 150 milligrams of caffeine. So the initial amount is 150 milligrams. Each hour, the amount of caffeine in her system decreases at that rate. So our rate is 0.12. Write and use an exponential decay function because it's decreasing. Find the amount in her system after 8 hours. So T equals 8. Then just put it together. 150, 1 subtract 0.12. It's a negative rate to the exponent 8. Type this in your calculator, and the answer is 53.95 milligrams. Done. Number 4, the half-life of mercury, 197, is 3 days. Write and use an exponential decay function to find the amount left from a 50-gram sample. So A is 50, T is 20. What's the rate that it's going? So half-life is 3 days. So to understand that it becomes 50% of its size after 3 days. So every 3 days, it becomes half its size. What's a better way to write this? So this is what we're going to do. So I'm going to use 0.5, but I need to understand it's every 3 days, not every day. Oh, and the time we're using is 20 days. Okay. So the first setup is simple. And then so 50 to begin with, that's the rate, and it's decreasing, but it's every 3 days. Now, t is every day, so if it's every 3 days, it needs to be t divided by 3. So we just have an extra part to it for that. And now our t in this case is 20. So we're going to put in this in our calculator. And then when you put that in your calculator, the answer is there's 0.49 grams left. The idea of half-life is the amount of days it takes to become half the size. So in 3 days, it'll be half the size it was. In another 3 days, it'll be half of that, half of that, half of that, and so on. Turn the page. Here's another question. Sometimes we're going to have a different formula here. Sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just after each year, each month, each day, and so on. The formula to the right can be used to find the balance of a count in this way. So we call this continuous increasing. So it's not every year, it's just continuously increasing. E is a number. P is the initial amount or the principal. R is the rate. T is the time. If it's decreasing, we put a negative number for R. If it's increasing, it's a positive number. All right, let's see if we can break this down. A garbage dumpster started with 4 pounds of garbage. So in this formula, that's what P equals, 4. The amount of garbage increased continuously. That's the key word that we're using this formula. And that rate is 0.35. Find the amount of garbage in the dumpster after 2 weeks. So 35% each day. So 2 weeks, we really have to do it in days. So that's why we're going to use 14. So 2 weeks is 14. So the formula then is 4e to the exponent 0.35 times 14. I wonder if you know where the number e is in your calculator. So it's 4 times e to that exponent. And if you put that in your calculator, it's 537.6 pounds. You might have to look to see in your calculator where E is. It's usually connected with this. I'm going to teach you what this is soon enough too. But ln and E, if you can find those, one of those probably is the second function to do it. On Desmos, you can find it easily on there too. Number 6. In number 6, the population of a town is declining at a continuous rate of 1.5%. So this is the key information. If the current population is 16,000, that's what I was looking for to begin with. Find the population in 8 years. So the rate is negative 0.015. Be really careful moving the decimal. The time is 8. And then put it together. So it's 16,000 E, that's a number, to the exponent negative 0.015 times 8. Put that in your calculator, get your answer, and you get, as a whole number, if you round it, it's 14,190. Can't have decimal people. So as a whole number, in 8 years, that's how many people are left for the population. All right, next part of the lesson, logistic growth function. Totally brand new for you. So let's understand it. Most things don't grow forever. Most things increase and then level off. This model represents that. so that things aren't growing to infinity. Things increase and then they level off. This is far more accurate of an understanding of it. So if and the formula that we're given here is right here. So that is C over 1 plus A times E to the negative RT. It is long and complicated. You're not going to memorize it. So C over that. Now C is a horizontal asymptote as well for it. So you can see that over here. C over 1 plus A times E to the negative Rx. And so let's see if we can interpret the equation here for number 7. So a disease begins to spread. Oh boy. Of a town of 20,000 people. This is too real. So after T days, the number of people who have been infected by it is modeled by the function below. And do you know, I mean, obviously we're filmed, right? I'm doing this we're in the middle of a pandemic, right? And so if I'm using this video and the pandemic's over, that's great. Math is being used to be able to figure this out. To know if we're in the purple tier, the red tier, the yellow tier, whatever it is. Math like this is used to determine where we're at. So if we're going to fight this disease, math is a key part of it to understand how to fight it. Okay, so after T days, the number of people who have been infected by the disease is modeled by this function below. Using this function, find the number of people infected after 10 days. So really all you have to do, because it's given to you, is you just have to plug this in. Now, the asymptote here, as it increases, 20,000 is the number of people in the town. So obviously it can't get past that. So when everybody's infected, the number is 20,000. So this function is going to increase. And then once it gets to 20,000 or close to 20,000, it's like done. Everybody's infected. It's over. Okay. And that's the rate of infection. So that's negative whatever it says, 0.95. Anyways, plug in 10 for T and then use your calculator. Use Desmos if you want, whatever, follow along. And the answer is 18,415. Boy. So already, only after 10 days, most of the population's been infected. When you look at infectious diseases and how quickly they can infect people, that is a math model that would likely scare most people if they understood the math behind it. So only after 10 days at that rate. Number 8. So a population of P in millions of a country from 1850 to 2000 is modeled by it. So we have 135 million. That's like the top of the population. It says find the population of the country in 1920. So the only challenge really is from 1850 to 1920. How many years is that? 1850 to 1920. So that's 70 years. And that's it. So plug in 70 and you have your answer. So as long as you're given the equation, it's not too bad. In calculus BC, we're going to be working more with these models and not so simply. So the answer is 12.19 in the calculator, but that's in million. So there's about 12 million people. All right, turn the page. And that's it. So there's your lesson on exponential growth. So we have these formulas we need to know. Boop, boop. We have this formula we need to know. And the last one. All right, Mr. G Math over and out. Until next time, I'm proud of you.